Good morning. Welcome back to Pre-Calculus with Mr. Leiston. I don't even know my name today. Mr. Leiston. So it's Wednesday. We're going to do the continuation of the notes from the guided samples from Monday. So open that up. We're going to get that out. We're going to go through a variety of different strategies that we have that can help us solve trig equations. So first off, we're going to begin at number 7 because on Monday we left off with number 6. Here we've got this cosine plus 1 equals sine. Cosine plus 1 equals sine. We're going to solve this from 0 to 2 pi. So we're going to have a restricted domain for that. Now here, struggling on what to do, how to approach this. A little bit of if we subtract the sine or subtract the cosine, if we have 1 equals sine minus cosine, there's nothing to factor. And further, we cannot factor if it's equal to 1. It must always be equal to 0. If we get everything on one side, cosine minus sine plus 1 equals 0, there's nothing to factor. Is there some way of changing from cosine into sine? Not directly, but there is one that we do know. We know sine squared plus cosine squared is 1. There's a connection between the two, but this isn't squared. Let's make it so it is. What I'm going to do is I'm going to square both sides. Now here, be careful with this. Make certain that you remember how to multiply because we've been doing it for 4 years of high school. We're going to distribute that out. We have cosine squared plus 2 cosine x plus 1 equals sine squared of x. And there's that. So now we've got a statement. Now if we subtract it, that's not 1. But this statement over on the right, this sine squared, we recall that sine squared is 1 minus cosine squared. So we can replace that, substitute out, and we get cosine squared plus 2 cosine x plus 1 equals 1 minus cosine squared. We use that strategy that we had the other day of rewriting something in terms of only one function. Now we can group everything onto one side and we'll see what happens. What I like, plus 1, the ones cancel. This subtract, if we add it to the other side, we get 2 cosine squared plus 2 cosine x. Oh, that's exactly the same, equals 0. We've got a statement that works is the same thing on both pieces. We'll factor that out. 2 cosine is what we'll factor because that's the common term. We're going to be left with cosine of x plus 1 equals 0. Because the factors equal 0, and it must always equal 0. Now we can set each individual factor equal to 0. We have cosine of x equals 0. If I divide by 2, I get 0 still. We have cosine of x equals negative 1 because I am subtracting that 1. And now we go to our unit circle. X equals 0, that's pi over 2 and 3 pi over 2. Keep in mind, we're doing this on the interval from 0 to 2 pi, so I'm looking for set values. I do not need the plus 2 pi k. Lastly, cosine of x equals negative 1. That's going to give us pi. So we've got those 3 solutions. There we go. There's number 7. Onwards. Number 8. It's one of those ones that's been giving us problems this week where we've got something more than just a variable in the argument of the trig function. Inside we call the argument. I've used that word quite a few times. There it is, argument. You should have seen that in the past. Working, we'll forget about that for a moment. We'll get everything else to the other side. We have cosine of 3t equals 1/2. If I add 1, divide by 2. Now here, cosine 3t equals 1/2. We need cosine of some angle equal to 1/2. Well, we know cosine is equal to positive 1/2. That's in quadrant 1. That's in quadrant 4. So what's inside could either be pi over 3 or 5 pi over 3. But the inside is 3t. We're going to have 3t equals pi over 3 plus 2 pi k. 2 pi because the period of cosine is 2 pi. Or we have 3t equals 5 pi over 3 plus 2 pi k. Just a matter of, this is multiplication. Each time we're going to cancel the multiplication, we'll divide. We've got t equals pi over 9 plus distribute fully 2 pi over 3k. We have t equals 5 pi over 9 plus 2 pi over 3k. And there we have it. Working with the argument, forget about that for the moment. Work with the trig function. Solving an equation, work from the outside in. All right, next up, that's a blank paper. That's a blank paper. Oops, how did that get in there? Don't want that. Number 9. Another similar, but it's tangent now. And we're going to work from the outside in. I'll subtract 3. I will divide by 3. So we're going to have tangent of x over 2 equals, subtract 3 gets us negative 3, divided by 3 gets us negative 1. That's on the circle. Now we have tangent of x over 2 equals negative. Forget about that. Tangent of something equals negative 1. Well, that something, tangent is negative in quadrant 2, in quadrant 4. Well, that's different by a space of pi, so that something has to be 3 pi over 4. So I'm going to set that something equals to 3 pi over 4 plus pi k. Reminder, tangent's period is pi, so I'm using pi, not 2 pi. Last step, if we've got x over 2 equals 3 pi over 4 plus pi k, we'll multiply both sides. We have x equals 3 pi over 2 plus 2 pi k. There's number 9. Nope, there's still 2 more. Okay, looking for exact values. Exact value. Well, we've been looking for exact values all the way along, but let's try this out. Now I notice secant squared minus 2 tangent. We've got 2 different functions there. But I know that secant squared, we can rewrite that as tangent squared plus 1 equals, minus 2 tangent equals 4. Get everything onto one side. We've got tangent squared minus 2 tangent minus 3 equals 0. Let us factor. We've got tangent of x, so needs to multiply to negative 3. Well, the only things that do that are plus or minus 1, plus or minus 3, adds to negative 2. So that's going to be negative 3. We've got tangent of x plus 1 equals 0. All right. Since the factors equal 0, we can set each factor individually equal to 0. The zero product property must equal 0. So we're going to have tangent of x equals 3. We've got tangent of x equals negative 1. Well, solving for this, we know negative 1. That's negative 3 pi over 4, excuse me. So x equals 3 pi over 4 plus pi k. Period of tangent is pi. Now 3 is not one of the values on the unit circle. So an exact value, how we would do this using the calculator is we would take the inverse tangent of 3 and it would give us some decimal point to it. We're going to do that except for evaluate. Thinking about this, if we had square root of 17, well, you could plug that into the calculator, but this is also an exact value. It does not involve any rounding. It is set. It's a number. So we're going to do the same thing with this 3 here. We would be taking the inverse tangent. So I'm going to write that out. Tangent inverse of 3. Whatever that angle is, this is an exact value. I have not plugged it into the calculator. I have not come up with a decimal approximation for it. Now the period for tangent is still pi, so we've got tangent inverse of 3 plus pi k. That's an exact value. That's done. Okay, something similar. X equals 2 sine of, Well, if we divide by the 2, we're going to have x over 2 equals sine of x. So sine of some angle equals that angle divided by 2. If we square both sides, we're going to have x squared equals 2 sine squared. We're looking for approximate solutions. So what we're going to do is, let's think about what this looks like graphically. From negative pi to pi, sine, we know, goes from 0 to 1, that's 1, down to negative 1. Oops, that should be a 2 because it's a 2. Change the amplitude, minus 2. And we've also got the equation x in there. Where'd my pen go? Lost my pen. If we graph so there's the graph of the right side. If we graph the left side, we're going to have some line that looks like that. When we're solving an equation, we want the points where they intersect. Now my graph is not perfect, so let's go to the calculator here. Also got this Q in, and I'm looking for approximate solutions. So I'm trying to approximate the solutions. I will look the decimal values where we cross on the graphs. We take a moment, let's pull that up in the calculator. Uh-oh, should have reset this before. All right, we're in y equals. Now, make certain that I am in degree mode. Don't need that. Mode, radian mode. We're in radians. Make certain that we are in radian mode. We're going to graph. I'm going to do y1 equal to x. I'm going to y2 equals to 2 sine of x. Now it's asking us for approximate solutions from negative pi to pi. I'm going to change our window to go negative pi to pi. I'm going to set the scale pi over 2 because I know the intervals for sine are pi over 2. I know the maximum minimum value for sine here is negative 2 to 2. But over this interval, I'm going to go negative pi to pi. And I'm choosing negative pi to pi because thinking about the range of the function x from negative pi to pi is negative pi to pi. If we go to our graph, there's x. There's 2 sine of x. There's one solution. 2 solutions we could probably guess at being 0. 3 solutions. So there's 3 different places to come at. If we're going to approximate these solutions, we need to find the intersection points. So I'm going to do second calc, go down to intersection, take my turtle cursor, go down first curve, and we know how this works. Second curve, take the guess. We've got x equals, you might not be able to see it there, negative 1.895. So we've got x is about negative 1.90. I'm going to round to 2 decimal places. I've got negative 1.895 for blah, blah, blah. I'm going to have that. We'll find the other solutions in there. Second calc, intersect. Take the turtle, put it close by. So the little turtle, so we arrow left and right, up and down, switches the curve. We have x equal, there's an exact value, x equals 0. And I'll do the last one as well. Hopefully we can guess that it's probably the same as this, but positive. But let's just make certain. And we have x is approximately equal to 1.895. 1.895. I'm going to round to 2 decimal places, 1.90. And there we have it, approximate solution. So with this, help each other. Try things out. If you're uncertain, send me an email. I will be checking periodically. I will be able to get back to you. Send me anything about what we have questions. If you do not have questions, if you submit perfect work because you went somewhere and somebody else gave you the answers, that makes it look like you've got everything set. We are having a quiz on Friday. You know the unit circle. You're supposed to know the unit circle. So try it out, help each other out, look for those patterns. Look for factoring, look for substitutions. Good luck, send me anything if you've got questions.